have filled in your domain, your range, your vertical asymptote, your horizontal asymptote. We didn't fill in the slant asymptote, right? And we didn't fill in the point of discontinuity. But we did the x-intercept and the y-intercept? We did? Okay. On the x-intercept, what did we say? Okay, so let's be a little more explicit on that. All right? Watch this. What? Yeah, it just means I'm going to explain it a little, make it easier.
Explicit means like sexual and stuff.
No, it doesn't.
It's explicit, like it's bad.
I don't think so. I don't think that's the only thing it means. I'll look it up, but I don't think that's the only thing.
State it clearly. Oh, go ahead.
State it clearly and in detail, leaving no room for confusion or doubt.
Oh.
Booyah!
Song is like bad.
They say explicit, yeah. But that's not the only thing. Okay? Yeah, y'all guys got really big. What is she doing?
It also means describing or representing sexual activity in an expressive fashion.
Okay, well, I'm not doing that, all right? So, and we're recording, okay? So, please, do we just need to start all over again?
Yeah.
Okay.
Yeah, I don't want my voice on there.
Yeah. What? Okay. All right, so here we go. Let me show you something. These are rational functions, right? So f of x is equal to, don't write this down, just look, okay? F of x is equal to, I don't care what it is. Don't write this down. Just watch. I promise you don't need it. I know, it's okay. All right, so let's look at this function. What if I wanted this function to equal, I want to find this x-intercept. I want this right here to equal to 0, right? Okay? In order to make this fraction equal to 0, what has to be true? What has to be 0? The numerator. Do I care about the denominator? No. So if I want a fraction to be 0, the top has to be 0, right? So go back to your little thing and in more detail, certainly not explicitly, set the top equal to 0 and solve for x. Isn't that easier? Okay, so just made it a little easier for you. All right, so let's talk about slant asymptote. Slant asymptote. First of all, here's the first thing you need to know. On a slant asymptote, it only has one if there is no horizontal asymptote. So, guys, if it's got a horizontal asymptote, it can't have a slant asymptote. It cannot have both of these things. It has one, or it might have the other. Okay? So, if it has a slant asymptote, what are you going to write? I mean, if it has a horizontal asymptote, what are you going to write by slant asymptote? None. Very good. Okay? Now, and, okay, it only has one if there's no horizontal asymptote. And the degree of the top is one more, not two more, not one less. It's one more than the bottom, than the degree of the bottom. Now, obviously, remember yesterday, if the degree of the top is bigger than the degree of the bottom, that's what makes it not have a horizontal asymptote, right? If it's top heavy, if it's bigger on the top than it is on the bottom, it doesn't have a horizontal asymptote. Well, if the degree on top is one more than the degree on bottom, then it will have a slant asymptote. And it will be y is equal to what you get when you divide the function out. When you divide the top by the bottom. Okay? And we'll do an example of them. It's not really bad. I think your notes will tell you what it is. All right, but we're not going to do it today. We're going to do it tomorrow. Point of discontinuity. Okay? A point of discontinuity is simply when a factor cancels. That's going to be where your point of discontinuity is. Okay? And I'll explain it to you. But we're going to try and work two problems today. Okay? We're going to try and work two problems. Now listen, I'm saying we're going to try and work two problems. I have 30 minutes, and I'm going to try and work two problems. Is that telling you about these problems? Okay? Now, of course, they're going to take us a lot longer because we're going to be talking about stuff and things like that. But you're going to need to get the hang of them, okay? And just like I told last class, this is what I did with your worksheet. Because next 6 weeks, the very last 6 weeks of the year, yes, only has 5 workable weeks, right? Because the last 6 weeks is the semester test week. And then one of those workable weeks is a crazy week where you guys aren't coming to school or something. You know what I'm talking about? Okay. We got another one of those, the star days, okay? So that's going to mess it up. So we're already cutting down. So the deal is I still have to have 6 daily grades and 3 test grades, right? So what I did with your review for your test is I broke it in half, okay? So I'm making it 2 grades. Okay, say, here's your options. Yes, you have to. Here's your options. Either I can do stuff like that, breaking stuff that you have to do up, or I can just give you a bunch of work. Okay? I mean, those are my only options. If I have to have 6 daily grades in, I have to have 6 daily grades in. So I can either take a review, which they're usually pretty long, and I can break it up, or I can give you your review and it's 1 grade, and then I'll find some other grade to give you something else. Okay? All right, so it's broken up. I'm glad y'all wanted it that way. That's the way it is. All right, so, do what? Peter. Oh my gosh. I'm not doing color by numbers. We got stuff to do, okay? We got stuff to do. Here we go. So here's our first problem. F of x is equal to, we're going to do a pretty easy one. We're going to go 2x plus 1 over x minus 3. Okay? Now, what we're going to do is we're going to list everything that we have to find, but I want you to leave room on the left-hand side to show a little bit of work. We don't have to show a lot of work, but we do have to show some work. So, we're going to find the domain. We're going to find the range. We're going to find the vertical asymptote. We're going to find the horizontal asymptote. We're going to find the slant asymptote. We're going to find the point of discontinuity. We're going to find the x-intercept. We're going to find the y-intercept. And we are going to have a t-chart that will justify our graph. And we will have a graph. Now you know why they take so long. We did do these last year. When we start to do them, you'll start to go, whoa, wait a minute. I think I've done these before. It'll be like a deja vu, okay? You'll recognize them, almost everybody. But remember what I told you. I'll let you use your cheat sheet on the test, okay? So this year you're not going to get to, all right? And don't tell the algebra kids they're going to get to, all right? Because I don't tell them until, you know, the day before the test or something. But I want them to pay attention and pretend like they need to really know it. All right. So the first thing I want to do is I want to find the domain. Look at your cheat sheet, and what does it tell you to do to find the domain? Zeros of the denominator. So all I do is take the denominator, and I set it equal to 0. X minus 3 equals 0. And so x is 3, right? Okay, so what do I do with that? Exclude it. So what is my domain? Very good. Negative infinity to 3, exclusive, union, 3 to positive infinity. Very good. Now, what about the range? What does it say on your cheat sheet? Look at your graph. Well, yeah, we don't have that, so we'll have to come back to that later. Vertical asymptotes, what about that? Zeros of the denominator. Do we already have those? Yeah, so we just, can I just write 3? No, it's not a number, people, it's a line. So x is equal to 3. All right, let's go over here and draw it. How do I draw an asymptote? A dotted line. It's not part of my graph, it's just going to help me graph. Okay? Dadgummit. Oh, there he is. Horizontal asymptote. As soon as I say horizontal asymptote, what should your brain think? Degrees. Okay? As soon as I say horizontal asymptote, you'll be, oh, that's the one about the degrees. Okay? So this is the only one that's a little bit difficult. So degree. How do you find the degree of something? It's what? The highest exponent. Okay? So look at this thing. What's the degree of the top? What's the degree of the bottom? Oh, that's equal representation. Do y'all remember that? That means that you have to represent the top and the bottom. So my equation is going to be y is equal to, what's the leading coefficient of the top? 2 over, what's the leading coefficient of the bottom? 1. So my horizontal asymptote is y is equal to 2. Let's go draw it. All right, slant asymptote. That's right. So what do I write here? None. If you leave it blank, what am I going to do? I'm going to mark it wrong, people. I'm taking your points away. It doesn't have a point of discontinuity. Y'all listen to me. That would be like if you had a factor on the top and a factor on the bottom that were the same and they canceled each other. Like you had an x plus 2 and an x plus 2, an x plus 2 on the top and an x plus 2 on the bottom, and they would cancel, then that negative 2 would become your point of discontinuity. Okay? He would no longer be an asymptote. He would be that. And we'll do that tomorrow. Okay? It's like a hole in your graph. Okay? And we're going to talk about it tomorrow. All right. If I zoom in, and we're going to look at one on the calculator, but just in general, you're not going to see it on the calculator. On a graph. I can see it on a T-chart. It'll say error, but it's not an asymptote. Okay? And how will I know it's not an asymptote? My graph's not going to what? It's not going to approach it. See what I'm saying? It's just going to come up there. It'll look like it ran right through it, but it didn't. Okay, so what about my x-intercept? How do I find an x-intercept? Make the top equal to 0. So 2x plus 1 equals 0. Subtract 1, divide by 2. What does x have to be? Negative 1/2. So my x-intercept is negative 1/2. Let's graph it. Where does it go, people? Yeah, it goes on the x-axis. It's an x-intercept. So put it on the x-axis. Now, do I know right now, look, we talked about rational functions. We know they're just those little curves. Do you know where this curve is? Because all you really need to know is it on the top of this asymptote or is it on the bottom of this asymptote? Yeah, I got a point right there, people. It has to be on the bottom. All right, let's find my y-intercept. How do I find a y-intercept? Okay, I'm just going to plug zeros in for these x's. I'm going to go back to my problem. 2 times 0 plus 1 goes on the top. And on the bottom, I have 0 minus 3. What is 2 times 0? Plus 1 is 0 minus 3 on the bottom. So what's my y-intercept? Negative 1/3. So he's about right here. Now, what my T-chart is for is my T-chart is to support my graph. Okay? Do I need to pick a point on the left-hand side of the vertical asymptote to support my graph being down here?
Oh, well, it doesn't support it.
Why? Yeah, I already got two of them, guys. I already got 2 points. I don't need another point. I know where this thing goes. Do you see what I'm saying? All right, do I need to pick a point on the right-hand side of this vertical asymptote? Yes, you do. Okay, because my knowledge doesn't support the graph on the paper. Do I know where it is? How do you know where it is? Because he went off the bottom, where does he have to come back on? The top. See, he's following that Pac-Man rule, all right? So he should be up here. Let's see if he is. What number you want to pick? Yeah, I just picked 4. So on the top, I have 2 times 4 plus 1. What's that? 9. On the bottom, I have 4 minus 3. So at 4, it's 9. And there it is right there. Yep. No, I'm going to let you slide with 1. Okay? I mean, if you had a professor and they wanted you to pick 3 or 5 points, you would know how to do it anyway. So I'm okay with it. So what's the only thing I lack?
Range.
The range. All right? So look at my picture and tell me what the range is. To what? To 2. Yep, it goes all the way up to 2. And then from 2 to positive infinity. All right, anybody got a question? Everybody okay? All right, let's try another one. Here's your next one. F of x is equal to 2x squared over x squared minus 1. I'm going to list all that stuff again. Domain, range, vertical asymptote, horizontal asymptote, slant asymptote, point of discontinuity, x-intercept, and y-intercept. Put a little T-chart out here. Draw me a graph. Okay. Are you ready? The best thing to do is to take your rational function and factor him, fully factor him. If you'll factor him right now, it'll make this job right here fast and easy. Okay? So, can you factor the top? No. So I just leave him alone. Can I factor the bottom? What does he factor into? Okay, now watch how easy I just made all my work. Domain. How do I find the domain? Yeah, look how easy they are now. I mean, you just look up there, you know exactly what they are. So if x plus 1 is equal to 0, then x is negative 1. If x minus 1 is equal to 0, then x is positive 1. So someone tell me what my domain would be. Union. Negative 1 to 1. Good, you got to go in between them. And then, very good. Okay, I'm going to go and draw my asymptotes. So I'm going to draw one at negative 1 and one at positive 1. I'm so glad this year's almost over. That thing's about to drive me crazy. Good night. So, at positive 1, Yes.
Over there.
My finger's supposed to work.
David is working. It's not collaborating.
I know, well, I was trying to calibrate it, but this thing was in the way.
Now it's not. Just click over. Just look at this bit.
Put that thing over there came out.
Denominator. Denominator. Look, maybe it'll let you click it. What in the butt?
That's enough. Oh, no, I never have. Okay, so, there's my, why did I do that? Sorry. Y'all, sorry. Yeah, I know it is, but we haven't even written it yet. I got all flustered. Okay, so, we can't do range. Vertical asymptote.
Negative 100.
Very good. Can I just write 1 and negative 1? No. You have to write x is equal to, and you can write plus or minus 1 if you want to, or you can do them separately. I don't care how you do it. And then I go over there and draw them. I've already drawn them. Okay? I'm going to go back here and see if my stuff is working. It says it's doing my address. Yeah, this is the last time I'm going to walk back here. I wouldn't even worry about it except that I was recording, so it's hard to hear when I'm up there. Okay. So now, horizontal asymptotes. When I say horizontal asymptotes, what do you think about? Degree. What's the degree of the top? What's the degree of the bottom? So that's equal representation. That was the cylinder base, right? Y is equal to, represent the top, leading coefficient of the numerator, over leading coefficient of the denominator. So my horizontal asymptote, y is equal to 2. That's not always 2, it just happened to be the same on these two problems. Okay? Now just so you think about this, do y'all remember, did we talk about what happens on the inside if you have more than one asymptote, vertical asymptote? What can be on the inside? Does anybody remember? A parabola that opens up or down, or a cubic curve. Okay? So it could be either a parabola that opens down or a parabola that opens up, or it could be one of those little cubic curve things. Okay? Alright. Slant asymptote. Nope. Doesn't have one. None. Doesn't have a point of discontinuity. X-intercept. How do I find an X-intercept? Set the top equal to 0. You see how much easier that is to do that? 2x squared equals 0. Divide by 2. X squared is 0. Take the square root. What is it? 0. Y-intercept. How do I find a y-intercept? Plug in 0 for x. Well, that's 2 times 0 squared over 0 squared minus 1. What's 0 squared? What's 0 times 2? If you got 0 on the top, I don't care what's on the bottom, people. Okay? It's 0. And of course that makes sense. There it is. Okay, so now I need some points. I need some points here to find out if my curve's up here and down here. What do you want to pick? -2. Okay? Now, I'm just going to do this because, I mean, really, I'd probably just plug it in really quick. But I'm going to show you how to do it on your calculator because we're going to have to pick some fractions in here. So I'm just going to go ahead and show it to you. Yep, there it is. Okay, so what I would do is I would put it in y equals, and then I would graph it. Okay, and then I would go second and calculate. Y'all, you're going to have a calculator on this test. Okay, I mean, will it help you see if your graph's right? Yes, but you're still going to be required to find all those things. So it might help say, yes, you're right when you found those things, but it's not going to help you find them. So we're going to do a value, so I'm going to choose number 1. And all I have to do is plug them in. If I want to know -2, I plug it in. 2.67, that's 2 2/3. So I go back, I write 2 2/3 on here, or 2.67, I don't care what you write. And it's right here. So that tells me where the curve is. Is my T-chart justifying my graph? Yes or no?
No.
Yeah. Yes, it is. Point, curve. All right. Now, what about this one? What do I have to do here? I need 2 points. I need one to the left and one to the right. Because even if I find one to the left and I find that it's down here, it might be a parabola that opens down, or it could be a cubic curve. Okay? So, I'm going to pick -1/2 and +1/2. Okay? And so, that's exactly right. It should repeat because I'm squaring both everywhere. But I'm going to go back to my little T-chart, my little calculator. I don't have to go second and calculate again. I can just plug it in. -0.5, -0.67. And then I can go +0.5, -0.67. So both of these are -0.67. So I'm going to graph them. Oh, yeah. So he looks like this. Everybody agree? All right. And then I'm going to pick another point. Right? What are we going to pick? So when you pick 2, what are you going to get? You're going to get 8/3. So at 2, it's 8/3 or 2 2/3 again. That's that squaring thing Chris was talking about a while ago. Or 8/3, however you want to write it. So he looks like this. Now, what's the only thing we haven't done? The range, okay? So, I'm going to be very particular about the range. So, you tell me what I'm going to expect. Negative infinity to what? 0. Included or excluded? Included. Y'all, it is a point. You see what I'm saying? Because he went right there, there's nothing in between here. So why would I go from negative infinity to 2? It doesn't. It goes from negative infinity to 0, inclusive. Union. Now where does it go? To what? Exclusive to positive infinity. Very good. Okay? All right. Anybody got a question? Okay, don't close your stuff up.